Hey friends, I am going to walk you through day one for the chapter one notes, lesson one. Forewarning, there's a lot of beeping going on in my neighborhood. So one of the things that I emphasized in my class for sure was the importance of paying attention to the verbs as you go through. So I want to make sure that you kind of think about that, and I'll highlight those as we go. So we're going to start off with something that you have seen before, and that is PEMDAS. PEMDAS is, please excuse my dear Aunt Sally. But in math, it's telling you the order of operations, and you have to do things in a specific order in order to get the proper answer. And this is actually something people struggle with for a really long time. So I think most of you know that the P is going to be anything inside parentheses gets done first. And if there's more than one set, you work your way from the inside out. Then you look for anything that is raised to a power, therefore it's called an exponent. Now here's where it gets a little bit tricky. The M and the D are for multiply and divide, and I'm writing them next to one another because you do them at the same time. You don't do all the multiplying and then do all the dividing. You actually just go from left to right, and in one sweep you do any multiplication or division that you see. And then in the last run through the problem, for the A and the S, you're going to do any adding, or if you have to subtract. And again, they're side by side because you do them simultaneously from left to right. So that is one of our concepts that is important. So just because of very long summers, let's take a look at exponents and just review that really quick. Here you have a math verb, evaluate. The root of evaluate is value. And so I'm going to jot that one down up here. Wait, first I'm going to spell it wrong. Then I'm going to go back and try again. So the root of that is evaluate is value, and you're going to be getting a value, a number answer. So kind of keep in mind that this should generate a number answer. And that's true like all throughout math. So pay attention to your verbs, because the verb is telling you what to do, and so then you should do that. So here it says to evaluate a power. So let's review powers a little bit. When you have a power, you're going to have a number at the bottom, and then you're going to have the power that's up in what we call a superscript. So this is your power, and this is known as the base. The power tells you how many times to repeat. So this is your number of repeats. And this base is the thing that gets repeated. So it's telling you what to repeat and how many times. So this example right here, 4 to the third, the base is 4 and the power is 3. So you're going to be repeating the 4 3 times, and it's repeated multiplication. So you can bust out your calculator or your big brain, and your answer or evaluated version of the answer is 64. So I should have a number answer. I'm finding the value. Next, we see another math verb, simplify. Now, simplify just means exactly that. Get it as simplified, or minimalize it as much as you can. That can mean a bunch of different things. Right now, you'll see there's no variables in here. It's all just numbers. So we're simply going to be using the rules of PEMDAS to get that down to one number. So I'm going to go ahead and do my parentheses first. So I just ignore everything else. So 4 minus 2 becomes a 2 in here. Now I see that there's a multiplication, the 2 times 5. I don't have any exponents in this one. So I go on to multiplication, and that gets done next. And so that turns into a 6. That turns into a 10, because math is apparently hard for me. And so I'm going to have 3 minus 10 and end up with a value of negative 7. Let's run through it again. Now here you're going to see that you do have a power, and it's inside the parentheses. So inside the parentheses, that gets done first. So this becomes a 25 minus 10. I'm still working on getting what's inside the parentheses done, so I'm going to have a 15 in there. Then the next thing I need to do is this division. So the one's just kind of hanging out because it's got addition with it. That turns into a 3. And when I am done simplifying, I just have 4. Simplifying won't always give you a number answer. If you have numbers, you'll get a number. If you have some x's, you'll end up with x's. We just currently have only numbers. So here, think about what the first thing is to do. Here the power of the 4 is on the outside of the parentheses. So I actually go ahead and do the 1 plus 1 first. And then I do 2 to the 4th. So think what 2 to the 4th is going to mean. 2 times 2 times 2 times 2. So it's going to be 2, 4, 8, 16. And then the next sweep, I have division. So I do that part first. So 24 minus, and then 16 divided by 4 turns into 4. So my final simplified answer is a 20. That's straightforward using PEMDAS. So now the next thing is looking at something that's really a key point. And this is problematic for me through most of my classes. Kids struggle with this forever and they rely on their calculator, but if you ask your calculator the wrong question, it will give you the wrong answer. So it's really important to understand this concept. You're going to see that these look really similar, -1 squared and -1 squared. But in this one, because of the parentheses, which is grouping it all together, you're telling your brain and your calculator to take -1 times -1. The entire thing is squared because the square will only affect the thing it's attached to directly. You know that when you take a negative times a negative, it turns positive. This one, however, the negative's chilling out front, and the 2 only is attached to the 1. So I end up with the negative out front and then 1 times 1. So ultimately, my answer is negative. So this impacts a lot of answers, and you might end up with a 50 or a -50, and they're absolutely not the same thing, right? Having $100 versus -$100 is pretty significantly different. So that's a key point, that even if you're entering it onto your calculator, you have to be really careful to see whether you're doing, like in this one, the whole thing, or the negative is floating out in front. Alrighty, so now we're back to evaluating. I'm always watchful for my math verbs. Evaluate the expression for the given value. What that's telling you to do is it's going to ask you to plug in the x value, and then you're going to go ahead and simplify using PEMDAS. So we're taking one step towards algebra, getting kind of back into those variables. So if x is -3, now it's negative, so you do want to be careful because there's a lot of negatives in this problem. It's -4, and then you are putting in for x -3, so you need parentheses around that, and then a -6, and then a -3 goes in for this x. And I'm really being cautious with my parentheses because I learned up above that that can make a big difference with my final answer. So I'm going to go back to PEMDAS. I'm going to do, I have parentheses, but they're just enclosing the -3, so there's nothing to do inside of them. That's my dog, Cinder. Hey, I'm making a math video. Be quiet. So if you square a -3, it would be -3 times -3, and it would turn positive. Here, I'm going to just write this in one swoop. So the only thing I did in that phase was the power. Now I'm going to go back and do multiplying. These two are going to become a -36, and here the negatives cancel to turn into a +18. And then I now have just subtracting and adding negatives and positives, so I can just go all the way from left to right, and I end up with -7. Here I'm plugging in a -1, so again, I'm going to be cautious with that negative sign and make sure that I'm putting that into parentheses everywhere. First thing I'm going to do is my exponent, so that -1 times -1 we learned up here becomes a +1, and then I'll go through doing my multiplication. These two become a positive, and then the only thing I have left to do is add. So I just keep going through the same process. I don't always have to do every step of PEMDAS. It just depends on what's in the problem. Now I'm looking at my verb, and my verb says to simplify, but now I have x power terms in there as well. I can't talk. So let's review what that means. So if I'm supposed to simplify and I have x's, I can't just use PEMDAS. So I will eventually, but if I have x's, I might need to do some other math as well. If there's parentheses with something sitting out front, I might need to distribute that, pass it out to everybody inside. Then I also will need to combine like terms. So all the plain x's would go together, all the x squareds would go together, and so on. And so I'm still going to be using PEMDAS, but I'm also going to be focusing on making sure that I end up with a simplified expression, meaning I'm still going to have x's in there. So this one doesn't have any parentheses. I don't need to distribute. I'm going to focus on collecting like terms. I start with the highest power of x, which is 3x squared, and there aren't any others. But when I see my plain x's, this is 1x plus 2x, so I end up with plus 3x. And then when I look at my plain numbers, I have a -5 and a +9, so that turns into +4. And then I'm done. Keep in mind that I like to go in what we call standard form. So I'm going to go from the highest on down to the lowest power of x. So here I have an x squared, then a plain x, and then no x. That is the ideal way to write your answer. In the second example, I have a 2 chilling out in front of these parentheses, so I'll need to distribute that. Most people are pretty good at that. Here's where it gets a little dicey, and it stays dicey. I struggle with this at all levels of math. You are distributing a -3. So -3 times a squared, but here -3 times -5 turns into a positive 15a. And then -3 times a positive 2 turns into -6. So you really want to kind of slow down and pay attention as you get to those with a negative out in front of parentheses like here. I'm going to write the highest power first, so that's this, and that negative goes with it. So I have a -3a squared, that's that term. Now I'm looking for plain a terms, not powers. So I have a 2 and a 15, and they're both positive, so that'll make 17 a's. And then for numbers, I have a -14 and a -6, and I'm combining them. I'm not multiplying, so the negative won't cancel. It's -14 minus 6 more, so I end up down at -20. Okay, now we switched verbs. There's a lot going on here today. Now we have to solve. When you solve, you are actually trying to, again, find a number because you're finding the value of typically x. Look, some of these look a little tricky because they have fractions. So I'm going to have to do one of two things. I kind of like to clear out the fractions. I'll show you both ways, especially when you have something like this upcoming problem where there's 2 fractions in the problem. I like to just clear them out because in this first example, I could just like wait till the very end. Keep in mind that when you're solving, you're undoing the problem, so you work backwards and you're trying to get to the x. So I'm going to get rid of the -2 first, and I'm going to do that by adding 2. So now I have 2/3 x equals 8. And then to get rid of a 2 over 3, I can multiply by 3 over 2 on both sides. And keep in mind the 8's over a 1 here. So this all cancels, and x turns into 24 on the top, 2 on the bottom, which reduces to 12. That's fine. But when you have more than one fraction, that can get tricky. So what I like to do is I look at the original problem and I think, okay, 2 is a whole number, so it's over 1. 6 is a whole number, so it's over 1. Now I'm going to look at these bottom numbers, 3, 1, and 1. What number can 1 and 1 and 3 all go into? And they can all go into 3. And I'll show you what I'm going to do. I'm copying the problem. I'm going to put this over 1 and this over 1. And I'm going to multiply everything by 3 because what will happen is 3 times 2 will become 6 over 3x, and that reduces to the whole number 2. In the second one, 3 times -2 is going to turn into -6 over 1. And then here, 3 times 6 on the other side turns into 18. And now I'm solving a problem that doesn't have fractions. So I cleared it out with that 3. So I get 2x equals 24, and when I divide it in half, I get 12. So, like I said, you might feel like this way is easier, but once you get to a problem like this, then it can get really tricky. So I'm going to go ahead and put 14 over 1 because it's a whole number, and I'm looking at the bottom numbers, 2 and 3. So I'm looking for a number that both 2 and 3 will go into evenly, and I think of 6. So I write the 6 over a 1, always over a 1, out in front. And any whole number in the problem, like the 14, I like to put it over 1 just so visually it makes sense to my brain. Top numbers multiply, so I get 6, and then the bottom numbers multiply, so I get over 2. But 6 over 2 reduces to 3, and when you use this process, you should always be wiping out the fractions. So like even here, 6 times 2 is going to be 12, and on the bottom, 1 times 3 is going to be 3. And so that's going to go reduce down to 4x. And then 6 times 14 turns into 84. This is super easy for me to work with now compared to what I had before, because now I can just say, oh, these 3x's and 4x's can go together, and then I can divide by 7 to get my answer of 12. Keep in mind when you're solving, you can always plug that back in here and here, so on a quiz or test you could check and see if you're doing it correctly. So this fraction method takes a little practice, but is well worth your time to figure it out. Here I see parentheses with things out front, so I'll distribute, keeping in mind that this one's going to be tricky because it's a negative. So I get 4x plus 8. And here, the negatives cancel, so I get positive 3x plus 3, because negative times negative turns positive in both cases. So if you kind of throw down your railroad tracks and think back to when you first learned this, I like to get the x's together wherever I won't get a negative. So in this case, I'm going to move 3, because then 4 minus 3 stays positive. Doesn't really matter, but I just like to keep the problem easier by not introducing negatives. And then to get x alone, I have to take that 8 away to the other side, and I get -5. And again, I could go back and plug that in for my x's to triple check and see if that is actually correct. Everybody loves a good word problem. So let's think. During one shift, a server earns wages of $40. That means you just straight up get paid 40 bucks. And additional 20% of in math means you're going to multiply by something, like 20% of what? And it's of the total sales. So they're basically getting a little commission or a tip on what they're selling. This is my total. It says the server earns 150. I always really focus on the question part. So I'm looking now, what was the total amount of sales? So that is the thing that we were looking at over here. That is my x. So I go into the problem knowing that x is equal to total sales. And now I need to turn those words into an equation. So don't make this harder than it is. You start by getting paid 40 bucks. That's your wage. It says an additional, so I'm going to be adding. 20% is 20 out of 100, so that really turns into 0.2. And you're getting 20% of the total sales, but we don't know the total sales, so we say 20% of X. And then you ended up getting paid 150 bucks. So your total payment of 150 is a combination of your straight up wage and the commission or tips or whatever you want to call it that you made off the sales. So we got to figure out how much money you must have sold. How much product did you sell in order to make that payment? So I'm going to take away the 40 to both sides. I'm going to have this 0.2x equals 110. And when I divide by the 0.2, I find out that I must have had $550 in sales in order to make that much money, that 150. Okay, so if there's any of these that confused you, make sure you take time to rewatch that part of the video. Have a great day, guys. Bye.